Alright guys, in today's video I'm going to show you how we solve simultaneous equations. So I have got 3 questions. Each question involves 2 linear equations and we're asked to solve for x and y. So I'm going to show you how we go about doing just that. The method is generally going to be to cancel one of the variables, to go from 2 equations with 2 unknowns and reduce it to 1 equation with 1 unknown that we can then solve. Okay, so question number 1, I have 4x plus 5y is equal to 1, and 3x minus 4y is equal to 24. So I want to cancel one of the variables, either x or y. I will choose to cancel my x. I have here 4x and I have here 3x. So in order to have the coefficients on my x term be equal, I'm going to multiply my first equation here by 3 and my second equation by 4. So if I multiply this equation here by 3 and this equation by 4, I will get, this equation becomes 12x plus 15y is equal to 3. It's my first equation multiplied by 3, and my second equation multiplied by 4 gives me 12x minus 16y is equal to 4 times 24. Well, 4 20s are 80, 4 4s are 16, that would be 96. Now, I have these 2 equations now multiplied by 3 and 4. The coefficient of my x terms are now equal, and I know that if I subtract these equations, my x terms will now cancel. So that's what I'm going to do. I'm going to subtract this equation from this one. I have 12x minus 12x will give me 0x. 15y minus negative 16y. 15y minus negative 16y is plus 16y. So that is plus 31y is equal to 3 minus 96. 3 minus 96 will be minus 93. And so I have 31y is equal to negative 93. Dividing both sides by 31, I get y is equal to minus 93 divided by 31. And therefore y is equal to minus 31 into 93 goes 3 times. So I get that y is equal to minus 3. To solve for my x, what I'm going to do is I'm going to take this value for y and I'm going to substitute it back into either one of my original 2 equations. That would be the easiest thing to do. So I'll do that right now. I'll sub it back into this first equation. And this first equation will now become 4x plus 5y is 5 times negative 3. That's equal to 1. Distributing out, I get 4x. 5 times negative 3 is negative 15 is equal to 1. And so therefore 4x is equal to 1 plus 15. Adding 15 to both sides. 4x is equal to 16. And therefore x is equal to 16 divided by 4. In other words, x is equal to 4. And so I have solved for both x and y. These values of x and y satisfy both of these equations right here. Okay, that's the first problem. Second problem is quite similar. I have 2 linear equations. However, what I want to do here is I'm just going to need to be a little careful. I notice that I have, in the first equation, I have x on the left-hand side and I have my constant term on my y on the right-hand side. And in my second equation, I have y on the left. And my x and my constant term are on the right-hand side. So I'm going to rearrange my equations such that I have x and y on the left-hand side and my constant term on the right-hand side. I'm going to choose to do it that way. So my first equation up here is going to become x minus 4y. All right, so I'm subtracting 4y to the left-hand side. And that's equal to 3. And my second equation, if I bring over my x term, my y term is already on the left-hand side. That will become minus 3x. I have plus y, and that is equal to 2. Okay, now that I have my x term and my y terms on the left and my constant terms on the right, I'm going to proceed. I see that I have here a minus 4y and I have here plus y. So I know that if I multiply the second equation here now by 4, I will have a plus 4y term. I will have a plus 4 coefficient on my y. And so that's what I'm going to do. Because I have here a minus 4y, I know that if I have here a plus 4y, I can simply add those equations together and I will cancel my y terms. My y terms will cancel for me. So let's just do that. I will multiply this equation here by 4, and it will become 4 times negative 3, that's negative 12x, plus 4y is equal to 4 times 2 is 8. Bring this first equation down, it will give me x minus 4y is equal to 3. And so now I see that because I have I have here a plus 4y and here a minus 4y, I know that if I were to add my equations together, my y terms will cancel. So let's just do that. Minus 12x plus x is minus 11x. My plus 4y and my minus 4y will give me 0y. And my 8 plus 3, that's 11. And so I end up with minus 11x equals 11. And so I can divide both sides of this equation by negative 11, and I will get that x is equal to 11 divided by negative 11. In other words, x is equal to negative 1. And just as before, in order to solve for my y, I'm going to substitute in my value of x into either one of my original two equations. Let's substitute into this one and solve for y. So I will get y equals 2 plus 3 times x becomes 3 times negative 1. And so y is equal to 2. 3 times negative 1 is negative 3. So therefore y is equal to 2 minus 3 is minus 1. And so I get x equals negative 1 and y equals negative 1. Those are my answers. Those are the values of x and y that will satisfy both of these equations simultaneously. All right, last problem is here. My first equation is 2x minus 3y is equal to 24. My second equation is a fraction, a 5x over 3 minus y over 2 is equal to 12. The easiest way to proceed with these sort of problems is to get rid of your fraction. That's my opinion. And so what I will do is I will multiply my second equation here across by some multiple that will get rid of those fractions for me. The easiest thing to do is to multiply by a common denominator of these two denominators here, 3 and 2. So a common denominator of 3 and 2 is 6. So I'm going to multiply this second equation by 6. Multiply that second equation by 6. And so I will get, multiplying it by 6, 6 times 5 is 30x. Divided by 3, that's 30x divided by 3 is 10x. And so I will get 10x minus 6 times y is 6y divided by 2, that's 3y, is equal to 6 times 12, that's 72. 72. And so I have now rewritten the second equation, but I've gotten rid of my fractions, and that makes my life a lot easier. I have, my first equation is 2x minus 3y is equal to 24. It's possible here that I might have to multiply this equation by some multiple also in order to cancel one of the variables. But I notice that I have here a minus 3y, and I have in my original equation a minus 3y. And so I'm happy enough to proceed like this, and I will simply subtract the equations one from the other, and my minus 3y and my minus 3y here will cancel if I do that. So my first equation is 2x minus 3y is equal to 24. And if I now subtract these one from the other, my y terms will cancel. So that's good. So 10x minus 2x, which is 8x, minus 3y minus minus becomes plus, and so I get a 0y. That's equal to 72 minus 24. 72 minus 24 is 48. And so I end up that 8x is equal to 48. And so I can now divide both sides of my equation by 8. And I get 48 divided by 8. In other words, x is equal to 6. X is equal to 6. And just as before, we can finish off our problem by substituting back in our value of x into either one of our two original problems. It's probably easier to substitute it back into this one. So that's what I'm going to do. I will get 2x will become 2 times 6. So that is 2 times 6 minus 3y is equal to 24. In other words, 12 minus 3y is equal to 24. Or 3 minus 3y is equal to 24 minus 12. That's 12. 24, subtracting 12 from both sides. And now I simply divide both sides of my equation by negative 3. And I will get 12 divided by negative 3. And so y is equal to 12 divided by negative 3 is negative 4. And so I get x is equal to 6 and y is equal to negative 4. Those are the values for x and y that satisfy both of these equations. And that is how we solve simultaneous equations.